Hello, Coach Holmes here, and today we're going to be talking about finding the measurement of segments in a circle when it comes to both chords, secants, and tangents. So for example, if I have two chords here, if two chords intersect inside the circle, which, by the way, if I haven't taught y'all, this is the abbreviation of a circle, where you have like a big circle and a dot in the middle. So that way it doesn't just be mistaken as a capital O. Then the product of the segment are equal. So I got two segments here. I got two chords here. So I got two chords here. One length is A, the other length is B. Since they're on the same chord, they're going to multiply to each other. And that's going to equal to the parts of the other chord, the product from the parts of the other chord, which is C and D. So the parts that are multiplying each other are on the same chord, and that's one of the biggest things we got to be able to remember. Now, two secant segment theorem. This one's going to be a little bit tricky, but it's doable. If two secants intersect outside of the circle, the product of the entire secant and segment outside of the circle are equal. So what does that mean? That means that the part outside of the circle times the whole secant is going to be equal to the same way on the other secant. So for example, the part that's outside is MI. And the part that's the whole thing is EI. And that's going to be equal to, to the part outside, Li, times the whole length, which is I, Y. So the product of those two are going to be equal to each other as well. All right, but remember, it's the part outside of the secant, outside of the circle, times the whole secant itself. That's what we got to remember. Now, tangent and secant is a little bit different, with one major difference. It's just one major difference. If a tangent and secant intersect outside of the circle, then the square of the tangent equals to the product of the entire secant and segment outside of the circle. So again, this tangent right here, that's squared. So jy is going to be squared. Now, if we're looking at the secant right here, ym is multiplied by ya. There we go. So while the tangent is being squared, if we remember what the secant does, which is the outside times the whole length, they're going to equal to each other. So let's look at a couple of examples. So I have 6 and x on the same chord, so they multiply to each other. And I have a 4 and a 15, and they multiply to each other. So 6 times x is 6x, 15 times 4, that's about 60. All we gotta do is divide 6 to both sides. X equals 10. So this length right here is actually 10. Now, if I look at number 2, again, this outside part times the whole length, which 12 plus 2 is about 14. So 2 times 14, or 2 times 14, or 14 times 2. Now, I have the x here, which, let me box that instead. So this whole thing is going to be x plus 3. So I'm doing x times x plus 3. And I'm putting it right here like this because it's easy to look at. All I got to do is distribute dx. 28 equals x squared plus 3x. Now, because we have 2 different x's, we got to be able to move this 28 over so we can factor. Now, this is the way I taught my Algebra 1 students how to factor, okay? And it seems to work very well. Draw a little box. So we say that the product is on top, negative 28, and the sum goes in the bottom, which is the 3. So the last number is always the product, the number in front of x is always the sum. Now, we got to think of 2 numbers that give us the product of negative 28, but the sum of 3. Those happen to be 7 and negative 4. So I'm going to write it out as x plus 7 equals, times x minus 4 equals 0. Now, one of them has to be it because I can't get a negative distance. That's not possible. I can't have a negative distance. So I'm going to split these 2 equally, split them up to where it's x plus 7 equals 0, x minus 4 equals 0. I'm going to move this screen up. Subtract 7 from both sides here. X equals negative 7. Well, that's not going to work. Now, add 4 to both sides, and I get x equals 4. That does work. So I can have a positive 4. So the distance for x is 4. And hopefully we won't be able to see this as often. Okay? Hopefully we won't see this. But that's a good possibility. However, on number 3, remember, this right here is going to be squared because it's a tangent. So 31 squared is equal to 20 times the whole length, which is x plus 20. So I'm going to have 20 times x plus 20. So I'm going to square the 31, which, my calculator's right here. 31 squared, that's about 961. Distribute the 20. 20x plus 400. Now I want to subtract 400 to both sides. That cancels out. 961 minus 400 is 561 equals 20x. And what I got to do with the 20? I got to divide it. So divide 20 to both sides. And x is going to give me 28.05. Okay? So the biggest thing we got to remember are these formulas right here. The parts of the chord are being multiplied to each other to get the other parts of the chord. Remember that it's the outside secant times the whole secant equal to each other for the other secant. And tangent squared is going to equal to the part outside times the whole secant itself. That's some of the things we got to be able to remember. Okay? These are what we got to be able to remember to define distance in a circle. Thank you and have a good day.